I'm going to share my slides. Can you see my chapter 6 slides?
Yes.
All right. We go on over factors affecting solubility, and we talked about concentration units. I'm going to go directly to ppm and ppb concentration units and do few calculations. Then we're going to talk about dilution problems, where you add water to a already known solution with already known molarity, and how you calculate new molarity from the data. We're going to look at that after I finish concentration unit. So we're going to continue this on the topic of water being good solvent and colloids and colligative properties. Let me go to ppm concentration. One of the concentration unit we use for pollutant concentration, which are present in the water and the air in small amounts, are expressed in ppm. ppm is same as percent composite, but use 10 to the 6 multiplication. In percent composition, we use 100%. We multiply by 100, fraction multiplied by 100 in percent concentration. In ppm, we fraction multiplied by 10 to the 6. If you look at a problem, a sample of seawater contains 1.3 grams of calcium ions in 3,100 kilograms of solution. What is the calcium ion concentration of the solution in ppm? So ppm is same as 1 milligram per, we talked about this, 1 kilogram of solution, 1 milligram per 1 kilogram. You convert this to milligram. It's going to be 1.3 10 to the negative 10 to the positive 3 milligrams of calcium ion. So we leave this as kilograms. You can convert that to milligrams also by multiplying. Kilogram to milligram is multiplied by 1,000 more, 1 million. Let's look at the idea I use. This is the fraction. When you do that 15 milligram, you get, this is same as 1.3 10 to the 3. So 1.3 10 to the divided by, this is kilograms converted to milligram. It's a multiplication by 1,000. You get 42 from 1.3 10 to the negative 10 to the 3. And This is the fraction you get. Therefore, you get 0.42. That's how you got the answer B. You start with 1 ppm is equal to 1 milligram divided by 1 kilogram and go on convert into fraction and multiply 10 to the 6. This is the fraction multiplied by 10 to the negative 6 divided by 10 to the negative 6. This is the ppm. You multiply 10 to the 6. In percentage, we multiply by 100. The maximum level of lead allowed in drinking water is this, 15 milligram. This is same as, do you see 1 milligram per 1 kilograms is 1 ppm? This is 15 parts per million. Therefore, answer should be 15. That's the answer. That's how you calculate it. Use the fact this is the definition of parts per million. Therefore, you put 15 here, 1 kilogram of solvent converted to 1 milligram. This kilogram converted to milligram. That's equal to 15 divided by million multiplied by million. You finally get that. The percent by volume concentration unit used in both solute and solvent are liquids. When you use percent by volume, that concentration. Normally we use volumes for liquid. Therefore, that's a 2 and 4. Percent volume is a constant use of both. Percent by volume is a concentration unit. We use both solute and solvent or liquid. That's correct. Percent volume is volume by volume. Therefore, both solute and solvent are. Now let's look at PPA, PPB problem. 30 milligrams in 1 kilogram is 13 ppm. How do I know? 1 milligram per 1 kilogram is 1 ppm. 30 milligram in this 1 kilogram is 30. So this is same as, that's for the arsenic in drinking water. This is not right. This is same, not same as. This is not right. This is correct. The same as 13 ppm. This is not right. Therefore, only correct answer is C. When you put this idea, ppm is same as 1 milligram per kilogram. Kilogram is 10 to the 6 milligram. So this is how we got the answer C. Concentration of lead. These are small amount of solute, which is lead, present in the water found to be 3 ppb. To which of the following is this equivalent? 3 ppb is equal to that's 3 micrograms in 1 kilogram. 3 micrograms is how many milligrams? 3 micrograms. Convert to milligram. Microgram is 10 to the minus 6 grams. Milligrams is microgram is 10 to the 3 milligrams. Therefore, 1000, that's the correct answer. Negative 3 times 10 to the negative 3 is this. A is the correct answer. I did the calculation here. You can follow up looking at the calculation, how I got answer A. A solution has concentration of 15 ppm. Which of the following is another way to describe the concentration of the solution? This is ppm. All units are given in ppb. Therefore, ppb is 1,000 times more than ppm because 10 to the 6, 10 to the 9. Therefore, this should be multiplied by 1,000 times. Which one is the, if you multiply 15 by 1,000, you get this answer. Answer should be D. All right. There's another problem. Which of the following is unit equivalent to 1 ppm? 1 ppm is, you check out each one. 1 ppm is 1 ppb, 1,000 times. This is 1 multiplied by 1,000. And this is weight percent. That means 1 ppm divided by 1,000. Weight percent is smaller than ppm by 1,000 times. 1 divided by 1,000 is this. ppb is ppm multiplied by 1,000. Therefore, you get 1,000. The answer to that question is both 100 ppb and 0.001% weight by weight. We're going to go a little bit more about changing concentration unit. Let's answer this question. If we know the solute mass and the molarity of the solution, which other concentration unit we can get without any other. Just solid mass and molarity is given. So mass is required, but volume cannot be, weight here cannot be obtained by volume of the solution. Therefore, you cannot calculate this without the density. You need density, which we call densities mass divided by volume. So you cannot calculate weight of the solution without the density. This is the only one. Here on top part, volume cannot be calculated by mass and molarity. Therefore, correct answer is B. Which of the following concentration units can be used when only the mass of the solute and the solution is known? That's that one. If the mass is and the solute and the solvent is known, this is the only one you can calculate, not this one. This is mass by weight by volume. This is volume by volume. A. Which laboratory equipment is best suited to prepare 100 milliliters of? We talked about volumetric flasks. There are flasks with certain volume. For this solution, what you use is 100 milliliter volumetric flask. So to prepare 100 milliliter solution, you have to use that, not that one. Pipette is not used to make solution. To measure volume of a liquid, you use a pipette. Pipette is a long tube with, you use a bulb to measure volume of the pipettes are used to measure the volume. Volumetric flask is used to measure volume of a specific solution. Answer is B. Let's look at this problem. This is again weight by weight. I am not going to go. Let me talk about density. I need to talk about this. When you have weight by weight, how do you convert it to molarity? That's the question. Weight by weight percent molarity. Molarity is moles divided by liter of the solution. This brass sample has total mass of 100 grams. From density, you can get mass converted to volume. Therefore, this is the denominator. Multiplied 8.4 multiplied by 100. 100 is the total mass. Then you have to convert what is the molarity. Zinc is the minor component. Therefore, zinc is the one that converted to, this is grams converted to moles. How do you convert grams moles? Divided by molar mass of zinc. This is major component. I was correct. 33 is the minor component. Therefore, you have to convert it. 33 grams is zinc. Divided molar mass of zinc is 65. You, from the periodic table, you can get. Therefore, number of moles of zinc is 0.5. Volume is calculated from density. Grams divided by density, you get 11.9. Therefore, moles of zinc divided by volume of the solution, you get 42. That's how you got 42. Answer is B. If you wish to prepare 250 milliliter barium chloride with this molarity, how much barium chloride is needed? Total volume is 250. So you can calculate from the molarity number of moles of barium chloride. We have to know the barium chloride formula weight. So this is the molarity of the moles of barium chloride. This is given here, 0.200. So you plug in this. How do you get 0.5? 0.5 is, that's the molar mass of barium chloride. Barium chloride is 208.3. You multiply moles, then you get the grams. To make this 0.200 molar barium chloride solution, you get 10.4 grams of barium chloride dissolved in 250 millimeter volumetric glass. That's the answer. How many grams needed to make molarity solution? Molarity of 0.200. If you wish to prepare how much water needed to be added to 1 molar. So here from the molarity you can calculate liters of solution. This is the molarity of the solution. Then you calculate the liters from the molarity. Therefore 2.4 liters. Answer is D. Molarity is a concentration unit we use for solutions. In chemistry labs, we use molarity. A solution is prepared by dissolving 3.5 grams of ammonium chloride in 250. What is the concentration? This is really simple. You get the formula weight of the ammonium chloride, convert grams to moles, and divided by liters of this solution. This solution has 0.250 liters. This divided by 1000 get the liters. This is the formula mass of ammonium chloride is. You have to calculate it. 53.5 grams divided by formula mass, you get the moles. Moles divided by 2 point. That's the liters of the solution. This is the moles of sodium ammonium nitrate, ammonium chloride. You get 0.262. That's the D is the correct answer. So we can do molarity calculation. This is the example. I'm not going to go here. You find the number of moles, find the liters of the solution, and calculate moles divided by liters, molarity. These are similar calculations. Let me look at this. What mass of barium chloride is in 200.200 molar barium chloride? So you calculate the moles, similar calculate moles of barium chloride by dividing from the moles liter with the molarity. If you multiply molarity by the 250 liters, you get the moles. Moles multiplied by barium chloride formula mass, you get barium chloride. This multiplied by 10.4. So there are, what is the mass? The question is molarity given of a preservative in wine, sodium bisulfite. What is the mass? From the molarity, liters 750. So you can calculate from the molarity grams of the solution. Grams converted to moles. This is the moles of sodium bisulfite multiplied by molar mass. Molar mass is 104. You get the 0.78, which is the C. We have done a lot of calculations. These are similar. You should be able to convert weight by weight percent to volume by volume percent, or weight by volume, either one of these. Or you should be able to convert molarity to one of the percent concentration, or including ppm and ppb. Now I am going to start on the idea dilution. Dilution is when you have a beaker of a solution with known molarity. Molarity of the solution is known. Molarity is moles per liter. You add water. The number of moles doesn't change, volume change. Therefore, due to the change of the volume, molarity would be different. How you calculate the new molarity? If you dilute means adding solvent, water in most cases. The number of moles of the solvent remain constant. There's a relationship. Moles multiplied by liters is molarity multiplied by liters. Therefore, if you have a sample with M1 initial concentration, V1 initial volume, therefore, this is the number of moles in the solution. If volume is changed, molarity changed, new volume is, there's still the number of moles should be equal to. That relationship is given here. If you know initial molarity, initial volume, and you added water, therefore this is known, then you can calculate new molarity by rearranging this equation. M2 is equal to V1 divided by V2. Let's look at the problem. How would you prepare 200 milliliters of 3.5 solution? Stock solution is normally the concentrated solution. In chemical labs, normally you use a concentrated solution to prepare whatever solution with required concentration. Therefore, in this problem, this is M1. They're asking what volume of this solution, and 3.5. This is 6.0. Therefore, you solve for V1. You get what volume should be added to. This is same calculation. 3.5 plus 200. You get, if you take stock solution, 0.012 liters, then add water, add water to prepare 2-liter solution, 0.2, that's 200 divided by 1000. Milliliter is converted to liters by dividing by 1000. This is the conversion factor, 0.2. Place, this is that liters converted to milliliters. This solution in a 200 flask is the one we use to prepare the 200 milliliter solution. And to stock solution, change the volume from 200 120 milliliters to 200 milliliters. So you get the required solution. Let's answer a few questions about dilution problems. The number of moles when you dilute a solution, what happened? What did we say? We said number of moles doesn't change if you add the solvent. Answer is there's no change. Number of moles of solution, number of moles of solute decrease, number of moles of solvent increase, number of moles of solvent decrease, number of moles of solute increase, number of moles of. When you add number of moles of solvent increase, answer C. Of course, solvent increase, but not the solute. Which of the following does not change in a solution after dilution, post-dilution? Does not change. That's the answer, B. Volume V1 in milliliters. Sodium bromide. Molarity is this. They're asking what volume. That's the V1. To prepare, that's the second solution with M2 molarity and V1. So to calculate V1, you have to rearrange M1 V2. So you do the calculation. This is the same equation I got over here. Then plug in the unknowns. You get 11.7. Answer is B. This is similar problem. V1, V2, M1. The unknown is M2. You solve for M2. A is the correct answer. If the dilute solution contains how many more? Once you get the molarity, this is the molarity of the new solution. Then molarity multiplied by new volume. New volume is this. Therefore, 0.789 multiplied by 1.60, you get the A as the correct answer. These are dilution problems. You find out what is unknown and calculate. In this case, if you read the problem, M1 V1 is initial solution. Final solution is V2. Question is concentration, M2. So you solve for M2 and plug in the unknown values. You get molarity of 0.59, which is answer B. What is the concentration of solution formed by adding water to? Now you have to, final solution is 65 plus 25, 90. So you substitute for values, you get the answer A, final molarity of the solution. Now I'm going to talk about water as a good solvent. Why water is a good solvent for making homogeneous solution or aqueous solutions to do chemical reaction. You guys have any questions? Let's look at how water dissolves ionic compound. Water is a good solvent. Ionic solid have positive and negative charge ions in it. We talk about regularly arranged solid ionic crystals. That's not a good. Water also dissolves polar molecules. Water is a good solvent for ionic compounds and polar compounds. Water has negative dipoles on the oxygen atom and positive dipole on the water is a polar molecule. Ions can dissolve by surrounding water molecules. We call it hydration, solvation, solvent molecules. Hydration means water molecules. For example, sodium ion could be surrounded by water with the oxygen and facing the positive ion. Negative ions like chloride ion, the arrangement is opposite, where the hydrogen end is towards the anion. Attraction between ions in water is called hydration. Solid also have hydrated water. For example, copper sulfate has 5 water molecules per 1 copper sulfate formula in the crystal structure. Therefore, hydration takes place in liquids and solids. We are talking about liquids here. One reason water is a good solvent is if you look at methanol molecule here. Methanol is CH3OH. There's a OH bond that can hydrogen bond to water. Therefore, methanol is a good solvent for polar molecules like methanol. The lines are drawn here to show the hydrogen bonding between methanol. Now I'm going to change the topic a little bit about water, how ionic solute, when solute is the ionic compound, what kind of properties aqueous solution of ionic compound has. If you dissolve an ion in water, they separate from each other. For example, sodium ions. When you dissolve sodium chloride, they separate from each other. If we put a electrode, there's a metal, piece of metal in the positively charged, you connect it to a battery. The positively charged is called electrode, is called cathode. Anode is the negatively charged. Cations goes to cathode. Anion goes to anode. So therefore, when you have a water solution of ionic compound, they conduct electricity. Therefore, they are called electrolytes. Movement of ion constitute overall electric current to the wires. Electrolyte is a substance that conducts electricity when dissolved in water. So whatever you dissolve, solute should have ions. Sodium chloride is an example. There are two types of electrolyte, strong and weak. Strong is mostly soluble ionic compound. Mostly soluble ionic compound or covalent compounds that dissolve in water. When they dissolve in water, covalent compound breaks up. For example, HCl, hydrochloric acid, in water breaks up to chloride ion and hydrogen ion. Therefore, strong electrolyte could be soluble salts or covalent compounds that breaks up completely. Weak electrolyte is mainly insoluble compounds. They have fewer ions in the solution. Or covalent compound that breaks up partially. Covalent compound that like acetic acid. It breaks up hydrogen ion and acetate to acetate ion. But this is partially. So you can classify if ions are in the solution. It could be a strong electrolyte or weak electrolyte. Non-electrolyte is substance that doesn't break up into ions in water. Non-electrolyte. How do you measure electrolytes? This is sodium chloride. Look at the glow in the bulb. It's strong. This is ammonia. That ammonia doesn't break up to completely. Ammonia become ammonium ion. But ammonia with water. Ammonium hydroxide. But this is only take place very little. Therefore, fewer ammonium ions are there. Acetic acid also classified for weak electrolyte. Non-electrolytes are no electro ions are formed. Therefore, like sugar, most of the organic compounds don't have ions in the solution. Therefore, called non-electrolyte. Electric conductivity is measured by a voltmeter or bulb is in this case. Higher the current passing through the circuit, higher the conductivity of the solution, Therefore, when the bulb glows brighter, it means strong electrolyte. How water dissolves covalent compounds? For example, HCl breaks up in water. That's almost 100%. Therefore, a lot of chloride ions and hydronium ions. Hydrogen ions in water exist as hydronium ion. That's this one, aqueous. So you can calculate how many, what is the molarity of the solution, knowing the volume of the solution. These are typical conversion of volume to gallons to milliliters. You have the conversion factor, liters, 3.785 liters is 1 gallon. So you can convert. We do need volume of a solution in many calculations. Let's do few problems. Which of those properties make water a good solvent? These are properties: surface tension, high specific heat, low boiling. Water has a high boiling point, high specific heat, high surface tension. The hydrogen bonding is the one that makes all these higher value of specific heat and high surface tension. Hydrogen bonding. Which of the following is a term water hydration applies? This is water molecule required to dissolve. Hydration is surrounding water. Ion surrounded by water molecules. Water molecule is in a solid is hydrated water. Hydration is not the idea. Which of the following term water hydration applies? The water molecules hydration. This is water molecule associated. This is the correct answer. This is present in the crystal. Water hydration is applies to. This is, to me, it looks like water molecules and also called hydration. But this is both A, B, and C is correct. Hydrated water is present in both liquid and solid. Which of the following is true of electrolyte? All electrolyte types. That's true. This is electrolyte need to have equal numbers. That's true. All electrolytes have mobile ion. That's true. All electrolytes. This is the most correct answer. All electrolytes have mobile ion. All electrolytes contain equal number. That's in certain cases, not always. All electrolytes mobile ion and contain number of cations and anions. This is not specific. This is the most correct answer. Types of electrolytes. An electrolyte dissolved only in water and no other polar liquid. There could be other polar liquids like ammonia. Therefore, that's not true. All electrolytes contain equal number of cations and anions. That's not true. All water and no other polar liquid. That's not true. Answer is none of these are true. Which of the following is a weak electrolyte? That's a soluble salt. This is a weak electrolyte. Ammonia, acidic acid, breaks up in water to a small degree. Therefore, they have fewer hydrogen ions and acetate ions. Both is not correct. This is strong electrolyte. That's not true. This one is true. But N cross with a negative, positive altogether become false. Neither is also not correct. Therefore, weak electrolyte is B. Which of the following has a higher electrical conductance? Therefore, you have to pick the strong electrolyte, which are ions. High electrical conductivity means higher ion concentration. Sodium chloride is a strong electrolyte. Both have higher. But when you have 0.2 molar solution, it contains more sodium chloride. Therefore, B should be the answer. Both is not correct. B is the correct answer. Higher the molarity, more sodium ions and chloride ions compared to 1 molar. Which of the following solution will have highest electrical conductance? Similar idea. All are 0.1, same concentration. But when the sodium chloride goes to solution, produce 2 ions, 1 sodium and 1 chloride. This one produce 3 ions. This one produce 4 ions. Aluminum ion and 3 chloride ion. 4. Therefore, having the same molarity, but ions dissolved in water produce 4 aluminum ions and chloride ion. Answer is highest electrical conductivity is C. Which of the following is true of electrolytes? Strong electrolyte dissociate completely into ions. That's true of the electrolyte. Strong electrolyte dissociate, that's not true. Weak electrolytes dissociate completely. That's not true. Strong electrolyte do not conduct electricity. That's not true. Strong electrolyte conduct the highest conductive has. A is the correct answer. Which of the following will have highest electrical conductivity? If you look at this. This is the highest molarity, but this is weak electrolyte. Therefore, it couldn't have the highest. There are few ions. This one is out. This is the weak electrolyte. Therefore, conductivity is lowest. Out of these two, this has higher concentration. Therefore, B is the correct answer. Highest electrical. Which of the following will have the highest electrical conductance? These two are weak electrolytes. Therefore, they have very few ions. Out of these two, B is the correct answer because molarity is higher. Which substance is the non-electrolyte? That's the strong electrolyte. Ammonium ion is a strong electrolyte, soluble compound. KOH is a soluble hydroxide. That's strong electrolyte. Hydrogen peroxide is a liquid. It is the non-electrolyte. Which of the following are electrolytes? Strong electrolyte. That's a strong electrolyte. This is the weak electrolyte. Hydrogen bromide, sodium hydroxide, sulfuric acid, which are strong electrolytes. They break up in water. In order for a solution to conduct electricity, it must contain ions and cis ions. Which of the following take place when HCl is broken down and dissolves in water? It doesn't react, it dissolves, breaks up. It results in a strong electrolyte. That's true. HCl doesn't react. So correct answer is so far A. Okay, it reacts with water. That's correct. The resulting solution is that's correct. Therefore, this is more correct. That's why C is the correct answer. I am going to talk about colloids and colligative properties on Wednesday. All right. After I finish chapter 6, we're going to have test 3 probably next week, Wednesday. All right. Do you guys have any questions?
No.
All right. I'm going to stop the class for today. We'll meet on Wednesday. All right. See you guys later.